Hello, everybody, and welcome to this webinar. Firstly, I would like to thank you very much for investing your time with us today. It's a great pleasure to have you all here on board. For the ones that doesn't know me, my name is Rafael, and I am one of the sales engineer for the low voltage drives and controls team based here in Brazil. And I would like to introduce you to Mauricio, which will be the presenter for the webinar. Mauricio has about 10 years of experience with drives and also working with WEG. So Mauricio will talk about the eco-design and the legislation changes in place to help on improving the efficiency on variable speed drives. So guys, before we start, I would like to touch base on a few housekeeping points to this presentation, to this event. Number one, your microphones will be in mute, and that's to assure that you have the best sound quality to all views. In cases you have questions, feel free to type those questions in the Q&A tab, so you can find on this webinar too. We have the whole sales team to backing us up here to respond to your questions accordingly. Okay, so next one, in case you miss any of the important points, don't you worry, okay? We will have available to you a recorded version of this presentation, so you can access anytime as your convenience. To access that, you need to access the LinkedIn page or our YouTube channel, okay? I highly recommend you guys as well to follow us on LinkedIn or on YouTube, where you can find the latest news about our products and also all the solutions we are building to suit you guys best. All right, without further ado, I think now it's time to pass it over to Mauricio. So again, thank you very much, and I hope you have a great time. Enjoy it. Bye-bye.
Rafael, thank you very much for the kind introduction today. So, hello everyone, and welcome to the webinar. It's a pleasure to me to be here today to talk about this very important topic, which is eco design. So, if you are in the European market, you probably are hearing a lot about this topic nowadays, especially if you work with electric motors and variable speed drives. So, in the very first day of this month, the 1st of July, the new regulation of electric motors and variable speed drives related to the eco design came into force. And there are some changes that happened. So you possibly are very curious about this topic and how to comply with that, because since this is a directive, you must comply to it, so you are in line with the law. So with no further delay, let's move to the presentation. So the webinar is Eco Design, Legislation Changes to Help Improve Efficiency in Variable Speed Drives. Here is the agenda of today. So first, I will be starting talking about the Eco Design. Firstly, the Directive 2009, which is the Eco Design Directive. And below the directive, we have the regulations. So the most important one, the one that we are going to focus today, is the regulation of 2019, the 1781, which started in force in this month. Then I'm going to talk about efficiency. Why, even though you are not in the European market, why you should care about efficiency. I'm going to bring some events of the regulations of eco design in a timeline, so you have a better understanding of that. I'm going to bring in the standards, the rules, the eco design in electric motors and variable speed drives, focusing on variable speed drives. And I'm going to explain some common terms on this topic. And then we are going to the most important part. How does the eco design apply to variable speed drives? What is the scope? And what are the requirements that for these variable speed drives? After that, I'm going to make some practical examples on how you can determine the IE class of the variable speed drive and the IES class for a power drive system. And in the end, we are going to have a Q&A session. So make sure if you have any questions, just post into the Q&A chat. Our experts will be responding to those questions. And if there's something open points, I'm going to answer into the end. So enjoy the webinar. So first, when we talk about eco-design, we are usually talking about the Ecodesign Directive of 2009. And the main goal of this directive is to reduce the environmental impact of energy-related products. But below the umbrella of the Ecodesign Directive, there are some regulations which are specific to each of these energy-related products. There are regulations for electric motor systems, lighting products, domestic appliances, office equipment, and so on. So the ones we are going to focus today are the regulations involving the electric motors and variable speed drives. And the one that is currently in force is the regulation of 2019, the 1781. This regulation replaced the old one, which you probably guys have heard about it. It was the regulation 640, 2009, which just spoke about electric motors. But this one spoke not only about the electric motors, but also about the variable speed drives. But why do we have eco-design requirements? Why do we have these regulations? So the European Union makes some studies, and they found out that electric motor-driven systems use about half the energy that they produce. So this shows the importance of making more efficient electric motor-driven systems. And how does the regulation will help on that? So first, they are setting efficiency levels for the motors, and specifically here talking about the variable speed drives. And as well, very important to inform the customers about these efficiency levels and if they are complying or not. So even though you are not in the European Union and you're possibly thinking, so why should I be more efficient? So the first thing to think about it is when you are more efficient, you are definitely going to impact less the environment that you are in. A second point, very important, is that let's take, for example, here, if you analyze a life cycle cost of a pumping system, of a typical pumping systems of a 20-year operation, you will see that the energy costs will account for about 45% of the total costs of this system. And only 11% of the costs will be the initial costs, the costs of installation this system. So when you are more efficient, you are going to save a lot of money in the future. There is a nice quote from Henry Ford that says, if you need to buy a machine and you don't buy it, then you will ultimately find that you have paid for the machine, but you don't have it. And here the same principle applies. So if you are installing a new system, if you just focus on the lowest initial costs and you don't evaluate the efficiency of the systems, you're definitely going to pay much more in energy into the future. So in a timeline, this is how the regulations ruling electric motors and variable speed drives have evolved in the time. They started in the past in 2011, but then these requirements have evolved. So more motors was included to the regulation, and so on. The requirements came more demanding, but until 2021, no requirements came to variable speed drives. But in 2021, in 1st of July the first day of this month. This new regulation that now replaced the old one, the new regulation 1781, now has more demanding requirements for electric motors, but there are two new things here. So in the past, you could use lower efficiency motors, IE2, with variable speed drive instead of using an IE3 motor. But this is now no longer acceptable. So this option ceases. And the second point, the most important one, is now variable speed drives, they also require to have some minimum efficiency levels. And in this case, the minimum efficiency level that now you should comply with is IE2. So again, we are talking here about a directive. So if you have a variable speed drive and it is under the scope of this regulation, you should comply to this directive to receive the CE marking, and thus your product can enter to the European market. So this is very important. And although there are some things planned for 2023, none of these things will change the requirements for variable speed drives until now. Nothing has to change in the future. Let's talk about the standards that rule the eco design for these equipments. So the IEC 61800-9, this series of standards, they rule the eco design for power drive systems, motor starters, power electronics, and their driven applications. And it is divided in two parts. So we have part one, which talks mainly about energy efficiency standardization using the extended product approach. That is the determination of losses of the extended product approach and subparts. And the part two, which is more the field of the variable speed drives, talks about the determination of losses of the complete drive module. We are going to come to these terms later. The power drive systems and the motor system. As well, this standard also talks about the determination of IE class and IES classes and their limit values of losses, and it also provides test procedures. Okay, so let's talk about some common terms. We have here some complete system since the mains and the main cablings and all the way through the load machine. And we have a lot of parts here. If you see right in the middle, we are going to have the complete drive module. The complete drive module, it comprises the feeding section, the auxiliary parts that sometimes have here, and the basic drive module, the BDM, and sometimes some auxiliary systems into the end. So basically here we have the most common rectifier unit in the input, and then we have the IGBT part, the inverter unit here. This is what we call the complete drive module. If we consider a complete drive module plus the motor, we are going to have the power drive system, which we call PDS. Similar to a CDM, or even though including the CDM, we have what we call the motor control system. A motor control system is either a CDM or other kind of starter. It could be a soft starter, a direct online starter, and so on. So this is called motor control system. And if you have a motor control system plus a motor, you're going to have a motor system. After the motor, we are going to have the transmission and load machine, which both together are the driven equipment, the equipment that the motor is going to be coupled and is going to drive. And all of this, the CDM or the motor control system, the motor itself, and the driven equipment is called the extended product. Okay, now that we can move forward since we have the basis, And let's talk on how the eco-design is changing variable speed drives and how those the eco-design affect the variable speed drives. So, but first, we have to understand what is the scope. So what variable speed drives are under the scope of the regulation? I'm going to use here the very same words that we have in the regulation, so it avoids any misinterpretations and you can have a clear understanding of what they are saying in the regulation. So the regulation says that the regulation applies to the following products, which are variable speed drives with 3 phases input that are rated for operating using only one motor and with rated power from 0.12 kilowatts up to 1000 kilowatts. And this motor is for rated voltage above 100 volts and up to and including 1000 volts. And these variable speed drives have only one AC voltage output. So to avoid any misinterpretations, the regulation already states what are the variable speed drives that are not part of the scope. So the requirements of the regulation shall not apply to the following variable speed drives. So one of them are variable speed drives integrated into a product and whose energy performance cannot be tested independently. So if you do that, the product won't be operative. They will be inoperative. Also, variable speed drives qualified specifically for safety of nuclear installations are not in the scope of this regulation. The regenerative drives are not part of the scope. Drives with sinusoidal input current as well. And the last addition of the regulation, it was an amendment in February of this year. So they made the last point here to make it very clear to everyone. Variable speed drives consisting of a single cabinet comprising variable speed drives, which are all in conformity with this regulation. So which means variable speed drives in a panel, they are not part of the scope of this regulation. But of course, the variable speed drives inside this panel should be in conformity with this regulation and the directive. So now that we understand the scope of the regulation, let's talk about which WEG products are included in the scope. So just to remember, the products included in the scope will be 3-phase power supply from 0.12 to 1000 kilowatts, from 100 to 1000 volts, and have only one output. Well, we will have here our mini drive, the CFW 300 is included in the scope. The CFW 500 and its variations, such as the HVAC drive, is included in the scope. The decentralized drive MW 500 is included in the scope. The CFW 500 and the CFW 700 and the CFW 701 is also included, and the CFW 11, as well as their variations, because we have some variations with high protection degrees. They are all part of this scope. Not included in this scope are the single-phase power supply drives, panels, and even medium voltage drives. Here we have the micro drive, the CFW 100. It has only single phase options, so it's not included in the scope. Panels such as the AFW 11 compact, the AFW 11 and AFW 11 modular are not included in the scope because they are panels. And as well, the medium voltage drives, MVW 3000 and MVW 1 are not included in the scope. Okay, so let's talk about the requirements. We know what products are in the scope of the regulation and the directive. Now let's understand if your product is in the scope of the regulation, what are the requirements for this product? So the main requirement is the CDM, the complete drive module, or a variable speed drive. It must be IE2, the efficiency level. How do you know if it's IE2 or not? So the IE class is defined from losses calculation at the point of 90-100, which is 90% speed and 100% torque. But the losses must be determined at 8 different points, which will be highlighted here in the graph, as well as the standby losses of the product. So here, this graph is based on frequency, basically speed, and then the torque producing current. So we're going to have a speed torque graph. And the 8 points are here in this graph. So you have all 8 points which you should have the losses informed to the customer. And the IE class is determined by the 90-100 point, which is this one here. So you might be asking, why do I need to define losses in 8 points if I just define the IE class with the 8 point here, the 90-100? The reason is simple. A variable speed drive is usually going to be applicable in applications where the load varies, and thus the speed of the motor is going to vary, or the torque of the motor is going to vary. And in these applications, the point of operation may not be the 90-100, but it could be something different, such as a 50% speed and 75% of torque. So using all these 8 points and using the methodology explained into the standards, you can define the losses in any point of the variable speed drive. So you can define the losses in the exact point that you are going to operate this product. Okay, so the regulation, if you look at the regulation, there will be tables defining the values of losses, and these losses were defined as a reference complete drive module, the RCDM. And these losses were named IE1. So if you have a reference values of IE1 and you need to be IE2, the standard says that you have to be at least 25%, you should have 25% lower losses than IE1 losses. Then you're going to be IE2. Okay. So IE2 is going to be lower than 75% of the losses of IE1. One great thing to mention is that all WEG drives that are under the scope of this regulation, they exceeds the IE2 efficiency level. And this is interesting because the regulation started in the first day of this month, but even though the drives that you have acquired before this date, their efficiency is the same as now, which means they were already IE2 efficient before. So if you have one of our drives, they are IE2 efficient. Okay, so we also have the power drive systems. One thing interesting, the regulation does not require an efficiency level for power drive system, although it's defined the IES class by using some loss calculations at the point of 100% speed and 100% torque. And therefore, if they define this level, you can go and see if your PDS is IES1, IES2. So this is still important, even though it's not a clear requirement. Perhaps in the future it's going to be a requirement, but until now there is nothing requesting that. So the losses here in the power drive system, They also must be determined at 8 different points for the same reason of the variable speed drives. And these 8 points are here highlighted into the graph. It's much similar to the variable speed drive. We have 8 points, but here the speed is going to be 100%. So the graph is for speed and torque. And then the point where it's going to define the IES class is going to be the point of 100% speed and 100% torque. Again, in the regulation, they defined losses values for a power drive system, and these values were defined as IES1. To be IES2, you have to have a power drive system with 20% losses than the IES1. Therefore, you are going to be IES2. A power drive system with WEG motor plus a WEG variable speed drive achieves IES2. You have to take in consideration that at least you should use an IE2 motor or better. But if you combine these two, the results will be IES2 at least. The regulation didn't only require the products to have a more efficiency products, but the regulation as well required that this information should be available to the customer. And therefore, they require to have some extra information into the labels of the product. So if you see here, this is a label of a WEG variable speed drive, and there is a specific label just for Ecodesign, Ecodesign label. And here you can find the year of manufacture, the IE2 level or the IE class, and as well as the power losses. Also, the regulation requires that to have this data into a website, into some public document that everyone can access and make their own decisions prior to buy this component. So we have this in our websites, and if you already have the variable speed drive, you can even access by a QR code. So if you go to our website, or if you access the QR code, it will be here. And then you can click in Download Center. And then you are going to go to Technical Notes. And you will have this file here, the Ecodesign information. If you click here, you are going to come to a document like this, which is specific to every variable speed drive. And then in the first column here, you're going to find the inverter model. And here in the inverter efficiency class, you're going to find the IE class of this drive, which now the regulation just define IE1 and IE2. So you're going to find all drives to be IE2. Okay, so these are the technical basis, and you're probably thinking how you can confirm these values or how you can calculate the IES class for a power drive system. I'm going to make some examples here for you so you know how to do this by yourself. So if you go to that exact same file, let's have an example here, a CFW 300, 4.8 amperes, 400 volts, which is this one here. It's rated for operation with a motor 2.2 kilowatts. And the output of this drive is 3.33 kVA. This drive, if you search here in the inverter losses relative to inverter apparent power, and you go to rated load, the 0.9100, you're going to see that it has in the rated operation 2.2% of losses. So if we make some calculations, we get the 3.33 kVA multiplied by 2.2%. We're going to have 73.26 watts of losses. This is the table of the regulation where you have the reference losses of the complete drive modules. And then let's get the reference value so we can compare with the one that we have in our drive. One important point to mention, the regulation states that if the apparent output power of a variable speed drive is between two values of this table, you should get the higher power losses, which means here we got the case where we have a 3.33 kilowatt drive, 3.333 kVA drive. It's a little bit above this guy here, so we should get the reference losses of this one, which is the 4.44 kVA. And then we are going to this value. So if we make the calculation, the reference IE CDM losses is going to be 299 watts. And the calculation here, I'm making in kilowatts. We're going to have 0.07326 kilowatts divided by 0.299 kilowatts. We are going to have 0.245 PU, or 24.5%. To illustrate better how it is classified into the graph here, it's going to be here. So to achieve IE2, we should be at least 75% of IE1. And here we are just 24.5% of the IE1 reference losses, which means we are much more efficient than the IE2. It's even more efficient. There is no classification of IE3 until now, but if it has, it's probably going to be classified as IE3. Similar calculation can be done for power drive systems. And here, the class is not IE, but IES. And let's make some calculation here, some example. I'm going to have the same drive for easy reference. I'm going to have the CFW 300, 4.8 amperes, 400 volts for a 2.2 kilowatts motor. And the losses, as you remember, it's 2.2% of the rated apparent power. If we calculate, the losses are going to be 73%, 73.26 watts. And here is one interesting thing. So the motor losses should be defined by the manufacturer. Here I got a reference motor from WEG, and the losses were defined as 372 watts. And then if we sum these both values, we are going to have in total 0.4453 kilowatts. This is kilowatts. I forgot the K. Okay. In the standard, we don't have these values into the regulation, but we have in the standard, IEC 61800-9-2. And these values works with the same principle. If you have a motor, you're going here to find the power rating of the motor, 2.2 kilowatts, our example. You are going to have the reference losses here in percentage and here in absolute values. So here, the reference says that the losses of the reference is 760 watts. And compared to the values that we have in our power drive system, which are 0.4453 kilowatts divided by 0.760 kilowatts, it gives us 0.586 per unit, 58.6%. The same here. Let's put in a graph for easy understanding. So reference is IES 1, and if you are below 80%, you're going to be IES 2. you are going to be in this system, you're going to be classified somewhere around here, 58.6%, which means this power drive system is IES 2. Very good. So basically, with that, I conclude the technical part of the webinar, which I explain everything. And before I move to the Q&A session, I would like to show with you where you can find more information about eco design if you are willing to learn more or if you need to find something in the future. So to find more information, you can go to our specific website for that, which is weg-ecodesign.com. Here you can navigate the web page and find more information, or you can just easily click here and download our guides about eco design. If you still have any questions or anything to share with us, you can go here in contact, where you can leave your information here and send us a message, or you can either contact us via email or via our address. Just a little bit of explanation. You guys heard me talking about WEG. Some of you know, some of you don't know WEG very well. So I'm going to talk a little bit of who is WEG. So WEG is a global company that has business divided in 5 main business units. We work with electric motors, automations, which is basically the part that we spoke today. That is the transmission and distribution part, the energy unit, and coatings and varnishes. The automation is still divided in many parts because we have a lot of products. We have the drives part, controls, safety, building and infrastructure, critical power, electric panels, solar energy, electric mobility, and the digital business. So we are a global company with worldwide presence. We have more than 30,000 employees worldwide, and we have 45 manufacturing sites over 12 countries. We have commercial operations in 36 countries, distributors and agents in 120 countries, and sales in more than 135 countries. Okay, I'm now in the questions and answer parts. So I'm going to check the Q&A chat if I have some open questions. And in the meantime, if you would like to, we have here some QR codes where you can point your camera and go and follow us in LinkedIn and YouTube. So you can watch past webinars that we made and you don't miss any updates about our solutions. Let me check here what we have in the Q&A. Just 1 second. Okay. There is one interesting question here. It says, for the power drive system, are input and output filters considered when we say all IES2? Yes, for power drive systems, the input and output filters should include the input and output filters. So if you're going to calculate the IES class, you should consider these 2 components as well and their losses to calculate the efficiency. Okay, there are no other open questions. I see some other questions here. Somebody is having difficulties in enter the WEG Ecodesign website. We are going to check. I tried this morning, it should be working. We're going to try that. Okay, there are no other open points. Again, Thank you very much for attending our webinar today. So this is it for today. And if you have any further questions, you can contact us via our website or any of our social medias. You can find us on LinkedIn and YouTube channel. And if you follow us there, you will be updated with our latest news, our new products, and future webinars as well. So thank you very much and see you next time.